Welcome back. So last time we talked about naming ionic compounds. Today we're going to focus on naming molecular compounds and acids. So as a reminder, right, molecular compounds are composed of two or more nonmetals. Right? So we don't have any ions here, we don't have any metals, we just simply have a combination of more than one nonmetal. Now, all the compounds that we're going to name in this section that we're going to learn how to name are what we call binary molecular compounds, meaning they have two elements. So all of these compounds are going to follow a basic structure. So we're going to look at the first element, and we're going to use the name of that first element, and we're going to specify how many there are with a prefix. Now, the prefixes we will use are similar to the ones that we used when we named hydrates when we talked about ionic compounds, except there won't be any hemi, and we've added a couple extra ones here for 9 and 10 just in case. So we're going to use these prefixes to specify how many of the element we have. Now, there is one exception to where we would not have a prefix, and that is we don't ever start the name with mono. So if the first element happens to have one of them, we would leave the prefix off. The second part of the name would be the second element, again ending in IDE, just like we did in the ionic naming system, and using the prefix to tell me how many of those we have. There will always be a prefix here, even if it's mono. And that's basically all there is to it. So let's look at these two compounds. Now, of course, the reason we need the prefixes is because the same two nonmetals can form various compounds, right? We saw this when we looked at the law of multiple proportions, right? Where carbon and oxygen can form various different compounds, just like nitrogen and oxygen can form various different compounds. And we have to have some way to dictate that. So, for example, right, we couldn't just call these compounds carbon oxide, right? If we just eliminated the prefixes, right, because they would all be the same. So we need to specify how many we have. So we got our first one, CO. So we're going to follow our pattern. So we have the first element, carbon. We only have one of them, so it would be mono, but we're not going to put that. So we have carbon. Then we go to the second element. We have oxygen, so it's oxide. We have one of them, so it's mono. Oxide. So carbon monoxide. Now, I will point out a couple of grammatical things that tend to come up. So you notice here I wrote monoxide instead of monooxide. So if you have a combination of two O's or an AO, then we eliminate the first vowel. So it would be monoxide instead of monooxide, or if we had tetraoxide, it would be tetroxide. We would eliminate the A. Now, other vowel combinations, we leave both of them. So if we were to have two I's, for example, etc. Now, let's go to the second example, CO2. So again, it's carbon, and we have one of them. So it's just going to be carbon. Now we go to oxygen, but this time we have two, so we're going to use the prefix di. So dioxide. So carbon monoxide versus carbon dioxide. And that's pretty much all there is to naming molecular compounds. It's really just a matter of a little bit of practice and remembering our prefixes. So prefix plus the first element with the name, prefix plus the second element, again, using that same ID endings that we learned when we named ionic compounds. So let's do a little bit of practice. So, first one. So we have nitrogen as the first one. I have one of them, so it'd be mono, but we're going to leave the mono off. The second element is oxygen, so it becomes oxide. We have two of them, so it's dioxide. So nitrogen dioxide. Next one we have one phosphorus. So we have mono, but we don't use the mono, so it just becomes phosphorus. We have three of the chloride. So the chlorine becomes chloride, and we have three of them, so it becomes trichloride. Down here, the first element, we have two iodine, so it's iodine. So prefix plus name of the element. The second element is fluorine, so we have 7 of them, so that's hepta. And fluorine becomes fluoride, so diiodine heptafluoride. We have carbon, we have one of them, so monocarbon, but it's just going to be carbon. And we have 4, so it's tetra. And it's bromine, so that becomes bromide. So carbon tetrabromide. And our last example here, we have sulfur. We have 3 of them, so we got trisulfur. And next element, we have 6 of them, so that's hexa. And it's fluoride, so the fluorine becomes fluoride. So trisulfur hexafluoride. So again, molecular compounds are usually easier for people to get the hang of once we get those prefixes down and we sort of understand the systematics here. Okay, so now let's move to naming acids. So first of all, let's talk a little bit about what acids are. So acids are molecular compounds that release hydrogen ions, which we're going to abbreviate as H+, when dissolved in water. So I'm going to underline this. So by definition, acids are aqueous, right? So in other words, an acid becomes an acid once it's dissolved in water, right? We could have the same material, but it be in a gas phase or some other not dissolved water, and it would not function as an acid, right? By definition, acids are dissolved in water, so they're always in the aqueous phase. Now, acids are, we'll learn much more about them if you take Chem 2, but just to go over a couple basic properties, right? For acids, they will tend as a group to have a sour taste, the ones that we eat, and we tend to eat a lot of acids like citric acid and citrus fruits and carbonic acid and carbonated beverages, and they tend to give things a little bit of a sour taste. they will dissolve many metals. So they react with most metals, not all, but most. And important for us is that the formula start with hydrogen. So one of the easy ways that we will be able to look at the formula of something and say, oh, that's an acid, is that all acids, their formulas will begin with hydrogen. Okay. Now, we have two basic types of acids that we're going to name. We have what are called binary acids, and these are simply hydrogen plus some nonmetal. They will contain no oxygen, right? And the second type of acid we have are what are called oxyacids. And as the name might imply, these are going to contain oxygen. Now, most of the time, that oxygen is going to be in the same sort of structure as one of our oxygen-containing polyatomic ions. So that can help us sort of recognize that they contain one of these oxygen-containing ions typically. Now, let's go through a couple examples of these just to kind of illustrate it, and then we'll do some more practice. So let's take a classic binary acid, HCl. Now, I'm going to try to get in the habit, as you should, when I write the formula of an acid, I put AQ behind it, right? And that helps you identify the fact that, oh, it's an acid, because, of course, HCl is a molecular compound that could just simply be named as a molecular compound, right? If we had HCl gas, right, it would be hydrogen monochloride. Just like we did with the molecular compound. So, but by putting that AQ there, we specify, oh, it's dissolved in water, it's going to function as an acid, right? Now, these binary acids, they always start with hydro. This is the only place in the naming realm, right, that we use this term, right? It's reserved for these binary acids. So it's hydro, and then we take the other non-metal, right, and we use the name of the metal, but instead of replacing the ending with an IDE, right, we replace it with an IC. So instead of chlorine becoming chloride, chlorine becomes chloric. So we have hydrochloric, and then just to make everybody clear that we're talking about acids, all acids will actually have acid in the name. So we have hydrochloric acid, common binary acid. So if you're looking at names, the giveaways, right, for a binary acid is the hydro, right? That tells me that it's just a combination of hydrogen and whatever the non-metal happens to be here, chlorine. Okay. So what about oxyacids? Well, these get a little bit more complicated. So we have two different ways to do this, right? So these are acids that contain oxygen. And again, that oxygen is typically going to be in the form of one of these oxygen-containing polyatomic ions. Now, if you remember when you were learning the polyatomic ions, right, some of them end in ate, some of them end in ite. So if the polyatomic ion, if the oxy ion ends in ATE, then the name of that will change to an IC. So the 8 will change into an IC. And then, of course, we end it with acid. If the ion ends in ITE, then the acid name will change to OUS, and have acid. So let's just look at a couple examples here. So I had H3PO4. So the PO4, right, that's the phosphate ion. And so you can see here that when we name it as an acid, that 8 turns into an IC and it becomes phosphoric acid. Now, here we have SO3, right? SO3 is the sulfite ion. And so the ite becomes the OUS and so sulfite becomes sulfurous. Now, I will point out that there are some sort of linguistic things that do come into play here that we just have to kind of get used to. So you notice that, it's not a true that we just pull off the ATE and change the ending, right? It's not phosphic. It's phosphoric. So we really do just sort of alter the ending. So phosphorus becomes phosphoric. And sulfur is weird, right? When we do this in acids, we don't actually take anything off the ending. We just add an OUS or an IC. So we could have sulfurous acid or sulfuric acid. We'll see. So it takes a little bit of getting used to understand what we take off or how we change the endings. But as more you do it, you start getting a little bit more used to it. So let's do some more examples. So here we're going to just name some different kinds of ions. So the first thing that we need to figure out is when we come up with an acid is it binary, is it oxy? So easiest way to tell that is, does it have oxygen? So no, so this is clearly a binary acid. And so that means the name is automatically going to start with hydro. And now, I didn't do it here, but we want to get in the habit of all of these, right? Should really, if we're going to name an acid, should really be labeled as aqueous. So we got binary, so the hydro, and then the nonmetal is the sulfur. So sulfur, again, is a little bit weird. So instead of being sulfic, it's sulfuric. And then we can see the IC ending. So hydrosulfuric acid. And I wrote this a little funny, right? This is all one word here. And so we don't have a space there. So let's look at HBr. So again, it's binary, right? No oxygen. Again, it's going to start with hydro. And then it's bromine, so bromine becomes bromic. And then, of course, with all of these, they're going to have acid in the name. So hydrobromic acid. Just like we saw on the previous slide, hydrochloric acid. So look at the next one, HNO2, right? This has oxygen, right? So this is an oxy acid. So no hydro. All we do is look at the oxy ion, right? So the NO2 ion, right? So the NO2 ion, that is the nitrite ion. And as we said, the ite becomes OUS. So this becomes nitrous acid. So the ite becomes the OUS. And here, HClO3, again, contains oxygen. So we identified the oxy acid. We identified the ion here. and that's the chlorate ion. And so 8 becomes ic, so it becomes the chloric acid. So chloric acid, as opposed to, again, what we saw on the previous slide, hydrochloric acid, right? A totally different material. Again, so this is why we have to have these sort of subtle differences in the names, right? We have hydro if it's a binary acid. We don't have hydro if it's an oxy acid. So that we end up with unique names for these different compounds. And lastly here, we again have another oxy acid. We see the oxygen here. So that oxy acid is the acetate ion. So it's an 8, so it's going to end in a C, so it becomes acetic acid. Okay. So again, a little bit of practice, and the biggest thing that I can tell you about these namings is the practice, right? I would also highly recommend, if you haven't already, to watch the other videos that I have in Talon, the outside videos showing different examples of naming and different practice, as well as just doing practice in the book and the homework, etc.